All right, so this should be page 207 in your book, and we are going to do a couple of problems together, but you're going to do several problems alone because by this time we've done some practicing. The problems that I plan on doing is number 9, number 10, number 11. So that's what we're going to start with so far. So looking at number 9, because it has fractions, I think that might intimidate some kiddos. So that's why we're going to do it together. In this kind of instance, I don't want you to be intimidated because, as you notice, it only has one term that has an x. So that means I can't put anything together. So 2 over 9 minus 1/5 x. Now they want an equivalent or an equation equal to that. So you can technically choose to multiply it by anything and just change the numbers around. So if I choose to change everything by multiplying it by 5, it's still the same expression. They've just made a piece of it 5 times bigger. No, I don't like that either. Okay, hold on. Let me rethink this because I don't like that answer. Okay, so let's just change the way that the fractions look because that's allowed. Because we don't want to change anything too big. We just want to change the fraction. So we know what equivalent fractions are. What I do to the top of the fraction, I'm going to do to the bottom of the fraction. So this one, I'm going to take 2/9 and I'm going to multiply it by 2 over 2. It doesn't change that. It's still the same thing. And then the 1/5, I'm also going to multiply by 2 over 2. And then I still got to stick the little x on. Now, I know that I'm taking up a lot of space, but I am writing with a mouse, so be patient. 2 times 2 becomes 4, and 9 times 2 becomes 18. Well, you should know by now that equivalent fractions, 2/9 is the same as 4/18, so I have not changed anything. It is still an equivalent expression. I've just changed to an equivalent fraction. And this one, I'm going to turn times 1 times 2 is 2, and 5 times 2 is 10. X. So big picture, and it doesn't look like I get a highlighter, but I can change the color maybe. What I want you to see is that this number, this fraction is equivalent to this fraction. This fraction is equivalent to this fraction, to the same thing. So all I did was change them so that I can write it a different way. It's very similar to what you do in these other problems, but fractions tend to intimidate students. It's not that they can't do that, it's just that it intimidates them. All right, so let's try number 10. Which expression is equivalent to t plus 2 or plus 4 plus 3? So I'm going to rewrite this because I know that I need that. So I'm doing t got moved, negative 2t got moved, plus 4 and plus 3. So I can put these two together. 1t minus 2t's makes a negative t, negative 1t if you will. It's the same thing. So I can write that negative 1t. Now it just looks like an h. Plus 4 plus 3 is 7. So again, I'm hoping you can read my writing, but negative 1t plus 7 is this answer right here. All right, so now we're going to look down a little bit further. If you need to pause, please do so. But we're going to look and do the problem below. I do not know how to clear the whole thing. I'm having to use a different app for all of this. There we go. Ta-da. So let's scroll down and see what number 11 looks like. The distance in feet that Karina swims in a race is represented by 4d minus 4, where d is the distance for each lap. What is an expression equivalent to 4d minus 4? Well, there's a lot of things that I can do here. I can do 2d plus 2d minus 4, which is an equivalent expression. I could recognize that those are both 4s, but this is, again, higher level thinking. And since they're both 4s, you know that distributive property? Well, if I take them away from both of the numbers, it's complicated, then I can also pull it out. So this is, again, one of those advanced type of things. So I'm going to pull the 4 back away from them. So I'm taking away what I gave them. So that 40 turns into 4, and this 4 turns into 1. That's another way. Again, not expected at this point, but it is something you could do. You could do 3d plus 1d minus 4. All of those are fine. All right, so when you start reading number 13, I want you guys to go ahead and try that one. Number 13 wants you to write an equivalent expression by the associative property. You guys remember associatives, those parentheses, and usually we use the associative property to group like terms. So push pause at this point, give it a try, see what you come up with, and then come check your answer. Okay, what I chose to do was W plus, and I just made my grouping symbols to go with the ones that go together. Plain and simple. Okay, we will continue on. I'm going to attempt to scroll down. Nigel is planning his training schedule for a marathon over a 4-day period. So that's over here. Okay. He is uncertain how many miles he will run in 2 days. One expression for the total miles he was run is 12 plus y plus 17 plus z. Okay. Use the commutative property to write an equivalent expression. Guys, it's just commuting. We're just moving. So again, I want you to pause and see if you can come up with a different answer. Okay, what I have done is I have moved my 2 variables together, and I put my 2 constants together, and we could solve the same way. All right, so that's number 13. At this point, I'm going to stop this part of the lesson, but I am going to scroll and make sure you guys know which ones you should not be doing. Number 17 is one you do not have to do. Don't put a bit of extra, but just remember 17 at this point. Not too worried about. We'll come back to it. But assessment practice would be very good. So all of the other ones that we did not do, I think we should work on during class on these various days as I instruct in the classroom.